Here we are at exercise 3, the first one where we can start doing some breaking, some really fun. You got a taste of it when I broke printf in the first exercise, but now we're going to do a little bit more extensive breaking. So I'm going to introduce you to printf, but you can read the exercise too. It's just an introduction to printf. It's not like everything about printf. Remember, the point of my book is I feed you tiny pieces of subjects, sort of interlaced, so that way when you understand a bit more about variable arguments, printf actually makes a lot more sense. In a later exercise, you implement your own printf. So that's the best way to learn how to do something. So the code. The code is very straightforward. You're printing out 2 lines. Now, I haven't done a full analysis, and I'm not going to type this in, but just remember, make everything exactly the same. Remember, you can do a diff. You can do diff, mine, and yours. Oh, exercise 3. You can do that to make sure that yours is exactly the same as mine. But also remember, that's cheating. So type it in, compile it, get it to work, struggle with it. The point is to actually really work with this. Okay. Now, the point of printf is for printing out. That's pretty much it. But there's a lot of variants of printf. There's like printing f for files, printing f to print into strings. It's all sort of old school stuff you don't really experience within modern programming, but you do have the concept of these format strings. This is something you get from Python, Ruby. Lots of languages have some way of formatting stuff. And the easiest way to explain what these are is they're simply just a template. You're saying, whenever you see this %d, there should be an argument that gets put in there. This is exactly the same as what you had with Python. So in this, I'm taking age and putting it there, like that, and height, put it there, and like that. The other thing that you have to do in C is you have to explicitly say when the line is like when you have a new line. So that's what these 2 things do. You should also know this already from other programming languages. And to do a more complete, this includes your standard I/O functions, and this is your main. Notice this main is a little different. You can get away with this, but really this main should be more complete. You can do that main there, and that's fine, but this is the one that should be more complete. Okay? Now, once I build this, just using your typical make, and then run it, and you're good. It's very simple. So the next thing we want to do is we want to break it. So the first thing is, hey, let's take age variable out of the printf call and see what it does. Let's copy that Makefile to here so we can clean, and let's also edit that Makefile. Let's put ex3 in there, and ex3. Oh, we don't even have that one. Yeah, let's just do it this way. That's easiest. Okay, so make, clean, that gets rid of that, make, builds that. Make ex3, make ex3. Notice we got our options. Okay, now we got some fancy stuff. Let's go here. Let's get rid of age. You already saw this in the first exercise, but let's just see what this does. All right, and then it also, because we have the dash wall, which is all warnings, that's what that does. We also get the age, we get the conversion, we get lots of errors. And remember, treat warnings as errors. There's an option in C to do that too, in the CC. Let's see what the next break, and then obviously that breaks it. So if we run it, you get to see that again, but you already saw what that does. It prints out a random weird error because it's getting it from a chunk of memory. When you build your own printf later, you'll see how that happens. Let's see. One thing we can do, you'll get into this later, but you have the LLDB program. So let's see what happens when we run it under there. Yeah, It seemed to work fine. On some systems, you might get a crash, and then you'll have a pointer. You'll have a breakpoint right where it crashed. So we can actually play with that on some other systems. We'll get more into that where we use the debugger and several other debugging tools like Valgrind and all sorts of other checkers to look for that kind of thing. Okay, so let's put the printf back the way it is, and then don't set age to an initial value. So that's an interesting one too. I do C code. Remember, the point of this book is to teach you like really solid C code. And one of the things that makes C code error prone is just how implicit and how just like you can just use random chunks of memory that are around and they don't get set properly and stuff. So what I find is I have to set variables ahead of time because I always forget to set them when I need them. And a good compiler will just set this up so that it doesn't cost you anything. And it'll give it a default value that will make sense. So I either set it to a default value that's reasonable, or I'll set it to a default value that's an error, like say -1 would be one here, or using a null pointer. We'll get into pointers later. So what I find is if you do this, it leaves junk in there. Now on some computers it'll do 0. On other computers it might have other junk in there. It just totally depends on the computer and the compiler. But if I do ex3 again, so now the compiler is being nice to me. It's saying variable age is uninitialized when used here. Even the compiler makers now consider this an error. Old C code, you used to be able to just say, oh, well, performance, and then you wouldn't initialize these. It's good to just start off right at the top, set it to something. So what happens when we run this? 0. That's usually what you'll see. And in fact, if you swear you set a variable, but it seems to always be forced to 0, this is probably what you did. But again, a different computer, maybe that part of the function call or the stack won't be set to 0. Maybe it'll just be some other junk. Let's see, what else can we do? We can probably do a few more things. So, oh, here's a fun one. So I'm going to do 100 for there. And instead of age, I'm going to accidentally do argv. This will be interesting. You'll see this is a really common error. It's a spelling mistake. Argv is very similar to age. So maybe you just like do some completion wrong or something like that. So what is argv? It's a character pointer. That asterisk means pointer, but it's actually a character pointer to an array of characters. It's for handling command line arguments. We'll get into that later. But what does this do when we build it? So again, we get another warning. Format specifies type int, but the argument has type char ***. Well, what does that mean? We'll get into it later, but basically it's saying pointer to pointer, character pointer to pointer. So that's not an integer. So C is a typed language. You have to have types that are the same, and you have to tell C what the types are. But it's not very strict about the types. You could kind of just go ahead and do whatever you want. And that's what this is warning me about. It's saying, hey, you're kind of just doing whatever you want. You said integer, but this is not an integer. So normally you would fix that, but what happens if we just run it? Again, we seem to get junk. As I said before, the rule is if you see junk, if you see weirdness, you see things just strange, it's memory. It's memory, 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 memory. So that's some fun breaking it. Go and see if you can do other things yourself. What happens if you edit the file? What happens if you try to print too much? Just come up with random things. What can you come up with? So that's your first extra credit. How many ways can you break it? Do man printf. Like that. And you'll see all the different printf formats. Read through this. You might be better off reading it online. You can do the same thing. Just go to Google and you type man3 printf. Add ex3 to the all list of your Makefile. One thing is, in the book, I'm assuming that you're not making separate little directories like I have here. So if you've been doing that, I apologize. You don't necessarily have to. But for example, they would just all be there. I'm doing it mostly for the videos, so that way I can keep everything clean. But you can put this all in just one directory, and then it's easier to compare with what you have. In fact, you could do the checkout if you wanted. You could do the checkout in a separate directory, and then just have make a directory down here. called code. Oh, code already exists. Oops. Oh, that's right. I made code. So you can just put your code in there. Okay, that's the end of exercise 3. Oh, let me make sure. I'll see you at exercise 4.